Good morning, 6th grade. Today we're going to be talking about molecules and compounds. And so, let me see if I could, there we go. Good. So, what exactly makes a molecule and what makes a compound? Why are they different and how are they different from atoms and elements that we talked about earlier? Well, start out with, we need to know what is a molecule. And so a molecule here is a group of two or more atoms bonded together. So look at the picture I have at the bottom of the screen there. All of those individual elements are just atoms. However, when you put two or more elements together, you create a molecule. And so the molecule at the bottom of the screen here is H2O, otherwise known as water. So water is not an element, water is a molecule. Now, most elements are naturally found as molecules and not alone. So for the most part, when it comes to any particular thing that you want to find an element, in nature, you have to find it combined with something else because that makes it more stable. But when it comes to things like your molecules you see here, that's the most common natural way to find them. Now, from here, we're going to talk about what exactly is a compound. And so a compound, substances formed of more than one kind of element are called compounds. So water is not only a molecule, found in molecules, it is also found and called a compound here. Water is the most common kind of compound. And so water is very interesting, and there are no water atoms. And so there's no atom of water. Elements come in atoms. That's the only thing that comes in atoms. Water comes in molecules, and so the smallest form of water is called a molecule. It is not called an atom. Now, there are a lot of different formulas that you can actually make for different compounds. Now, to write out the formula, what you need to do is first write down the symbols of both or more elements. So with one of the examples I'm going to show you a little later on, you're going to see that you can actually have more than one different type of element in your compound. Now next, you write down the number of each atom in the molecule next to the symbol. For example, right here we have H2O. And so there are two hydrogens, so the 2 is next to the H, and only one oxygen. Now, we don't put a 1 next to the oxygen. Let me make this very clear. I'm going to say it again. You do not put a 1 next to the oxygen if there is only one oxygen. Alright? Now, this system can be used for all molecules. For example, glucose has 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. It should be atoms, not molecules. And then from here, it is written C6H12O6. Now, you see this here. This is not a typo. This is purposefully done this way so that the 6 is at the bottom. Here, that is what we call a subscript. And this would be glucose written out. 6 carbons, so the 6 goes here. 12 hydrogens, so the hydrogen 12 goes here, and then oxygen, 6 of them, so they go right here. Now, here are some more examples. Let's see if you can get them before I put them up. So table salt has 1 sodium element and 1 chlorine atom. And so there's 1 of each. So you'd look on the periodic table and you'd find sodium, and you'd put down sodium's symbol, and then you'd find chlorine, and you put down chlorine's symbol, and that would be your answer. There's no other things that need to be done for this one here. And you can see here, sodium is Na, chlorine is Cl, and that is regular table salt. Now from here, carbon dioxide has 1 carbon atom and 2 oxygen atoms. And so to show this one, you're going to put the carbon down, you're just going to put a capital C, and then you're going to put a capital O for oxygen, and then you're going to put a 2 to the bottom right of the O because there's 2 oxygen atoms, and it'll look like this. CO2, carbon dioxide. This is actually what you breathe out when you blow air from your body. Carbon dioxide. Now from there, we have copper sulfate. Now copper sulfate is interesting. We have 1 copper atom, 1 sulfur atom, and 4 oxygen atoms. So I want you guys to write that down there. And this is an error here. It's supposed to be an A. I don't know how that went past. That's weird. Well, it should look like this. The Cu is for the copper, the S is for the sulfur, and the O4 is for the 4 oxygen atoms. So notice right here, the 4 is next to the oxygen. When there's only one of that type of element, you don't have to add a number, all right? We didn't put Cu1, S1, O4. No, we just put Cu, S, O4. Now from here, there are some compounds that are what we call non-molecular compounds. They're not bonded together in any real way. Now, these compounds are composed of individual molecules that fit together, kind of like puzzle pieces. Now, table salt, NaCl, is the most common non-molecular compound. There's no real bonds here. They just kind of fit together in that way. Just like you can see here, this is table salt. And you got the Na positives, and they fit in next to the Cl negatives. And they're attracted to each other because the Na, or the sodium, is positive and the chlorine is negative, and so they kind of bond together in that sense, almost like magnets. So it says right here, instead of the different molecules bonding together, they fit more like puzzle pieces to form a crystal. And so when you've seen like sugar crystals or salt crystals, it's really just a huge mass of all of these right here. And so that's what's going on there. So a salt crystal is a whole bunch of these sodiums and chlorines just attached to each other. Now, here's some other types of crystals that we can have as well. Diamonds are made of networks of different carbon atoms. This makes the diamond very strong. Now, at the bottom here, I have an example of diamond and graphite. Now, right here, these diamonds, you can see how the bond is more interconnected, more locked together, compared to graphite. Now, graphite's very plain. Diamond is obviously the diamond that you would find on fine jewelry at the end of different saw blades and things like that, but graphite is actually used in pencils. So it's the same carbon, but completely different bond, and that's what makes this diamond here a crystal and this graphite here a completely different looking thing altogether. Now, diamond is the hardest of all known structures, and this is true. That's why diamond is so valuable. Not only is it valuable as a rare, precious gem, but it's also extremely valuable in cutting things. Diamond-edged blades are used to cut glass and to do all kinds of different things that are extremely important. And because diamond is so hard to find, it is also very expensive and is only really possible to be made outside of the laboratory. If they were able to make diamonds in a lab, all of the value for diamonds would fall significantly. And so, since we haven't found out how to do that yet, diamonds are very costly. Now, another very popular crystal is ice. Ice forms different crystals on different objects, and they look almost similar to the way diamond forms crystals, where it's 1, 2, 3, 4, 5, 6 water molecules really fitting together to create the ice crystal. Now, I believe that is all we have for today. I'm going to have you guys do some more of these for your classwork today. I'm going to give you a couple of these examples for different elements. I'm going to ask you to write out the name just like I did here, or the symbols. For table salt is NaCl, carbon dioxide is CO2, And then copper sulfate is CuSO4. You're going to have to use your knowledge of the different elements and what their symbols are and things like that. And so, hope it goes well. Any questions, just message me on Google Classroom and I should be able to get to them. I hope you guys have a wonderful day. Thank you and goodbye.